Let me ask you something. What is the most feared predator in the ocean? Most people answer this one instantly, without hesitation. The orca, killer whale. An animal so dominant it has been documented hunting great white sharks, drowning blue whale calves several times its own size, and coordinating attacks with a level of precision that has earned it across essentially every ocean on the planet. The informal title of apex predator, the animal that answers to nothing else in the water. Orcas have been recorded working in teams to deliberately create waves that wash seals off ice floes, isolating them before they even have a chance to fight back. They have been documented systematically targeting the livers of great white sharks with surgical precision, and doing it well enough that entire populations of sharks have been observed abandoning traditional hunting grounds the moment a particular orca pod moves into the area. If any single species has earned the reputation of having nothing left to fear in the ocean, it is this one. So here is something that should not make sense. There is an animal living in the same water as orcas, an animal roughly a third of an orca's weight, with a face that looks, if I am being completely honest, a little goofy, a bulbous, rounded forehead, and a permanent, faint smirk that makes it look more like an oversized cartoon character than a threat to anything. And when this animal starts calling nearby, fully grown orcas, animals that fear essentially nothing else in the ocean, go silent, stop whatever they are doing, and swim away as fast as they physically can. Not retreat cautiously, not reposition. Researchers tracking these encounters have recorded orcas sustaining high-speed swimming for miles, specifically to put distance between themselves and this other animal. This is not an occasional, isolated behavior either. It shows up consistently enough across multiple documented encounters that marine biologists now treat it as a genuine, predictable pattern, not an anomaly. I want to understand how that is possible. How something so much smaller than the ocean's most feared predator has apparently convinced that predator over and over that the smart move is simply to leave. Stay with me, because the answer involves diving into pitch darkness at speeds that should not be survivable, a genuinely strange acoustic weapon, and a survival strategy built entirely around a single, brutal piece of evolutionary logic. And by the end, I think you will understand why some marine biologists half-jokingly refer to this animal as the ocean's most effective mob enforcer. Let us start with what this animal actually is, because if you saw a photograph of one without any context, you would probably never guess what it was capable of. This is the pilot whale, and despite the name, it is not technically a whale at all. At least, not in the way that word usually gets used. Pilot whales belong to the dolphin family, the same broad, taxonomic group that includes orcas themselves, since orcas are, biologically speaking, also dolphins, just an unusually large and specialized one. Pilot whales are, in fact, the second largest species of oceanic dolphin on the planet, ranked immediately behind the orca itself. A fully grown male pilot whale can reach roughly 20 feet in length and weigh close to 3 tons. Here is a number worth sitting with for a moment, because it frames everything that follows. 3 tons is genuinely large. It is roughly the weight of an adult African elephant. This is not a small animal by any reasonable standard. And yet, when you place it directly next to an orca, an animal that can weigh up to 6 tons, double the mass of a male pilot whale, with a mouth built specifically to shred through flesh and bone, the size difference alone should settle the question of who wins an encounter before it even starts. If dolphin, as a word, conjures up images of friendly, playful animals doing tricks at a marine park, leaping through hoops for a fish reward, I want you to set that image aside completely, because it is actively getting in the way of understanding what you are about to learn. The dolphin family, taken as a whole, is considerably more violent than most people realize, and pilot whales sit near the sharper end of that spectrum. So the obvious question becomes, what exactly are pilot whales doing that convinces an animal twice their weight to simply leave? And the answer starts not with how they fight, but with how they eat. Most dolphins hunt fish relatively close to the surface, in reasonably lit water, using speed and coordination to corral a school into a tight, manageable group before feeding. It is, by ocean standards, a comparatively low-risk hunting strategy. Pilot whales do not do this. Pilot whales hunt squid, and specifically, they hunt deep-sea squid, which means diving into water that most surface-dwelling animals never experience directly at all. To reach their prey, pilot whales regularly dive to depths exceeding 3,000 feet. Let me try to put that number somewhere you can actually hold on to it. 3,000 feet is deep enough that essentially no usable sunlight remains at all, a zone of complete and permanent darkness. Water temperature at that depth sits just a few degrees above freezing, and the pressure at 3,000 feet is intense enough that an unprotected human body would be crushed almost instantly. An environment that, by every ordinary measure, reads as actively hostile to air-breathing, warm-blooded life. For comparison, a recreational scuba diver rarely descends much beyond 130 feet, and even experienced technical divers pushing the outer limits of what human physiology and equipment can withstand very rarely approach even a tenth of the depth. A pilot whale reaches routinely, on a single breath, without any equipment at all beyond the body it was born with. And squid, the prey pilot whales are chasing down there, are not slow, passive targets. Squid are essentially pure muscle, propulsion systems built for rapid escape, capable of shooting through open water at genuinely startling speed the instant they sense a threat. Catching one is not a matter of drifting patiently until an opportunity wanders by. It requires an active, committed, high-speed pursuit, conducted entirely on a single held breath, in total darkness, under pressure that would immediately kill an unprepared human diver. Here is what that actually demands of a pilot whale's body. They hold their breath, descend rapidly to that crushing depth, locate a target using echolocation, since there is no light down there to see by at all, and then sprint, committing an enormous, explosive burst of muscular effort and oxygen consumption to actually run down a fleeing squid before it escapes into the surrounding darkness. Their muscle tissue is adapted specifically to store far more oxygen than a surface-dwelling mammal's would, dense with a protein called myoglobin that allows the muscles themselves to hold a private oxygen reserve, separate from what is carried in the bloodstream, extending exactly the kind of explosive physical effort a high-speed chase in total darkness actually requires. Once the hunt is successful, or unsuccessful, they then have to make the entire journey back to the surface before their oxygen runs out completely. A return trip that, for an air-breathing mammal running on a body already pushed close to its physical limit, carries its own very real risk. This is, by any reasonable definition, an extreme athletic performance repeated routinely as a basic requirement of daily survival. A pilot whale is not simply a large animal. It is an animal built specifically to sprint, at full physical commitment, in conditions of total darkness, crushing pressure, and near-freezing cold, purely to catch a single fast-moving meal, over and over, dive after dive. That alone tells you something about the kind of physical conditioning packed into this species. But it still does not explain why an orca would ever be afraid of one. Being an impressive deep-diving hunter does not automatically translate into being dangerous to the ocean's most feared predator. So let us look directly at what happens when the two species actually meet. Marine biologists have used underwater hydrophones, sensitive underwater microphones capable of capturing sound across the full range these animals communicate in, to record and study exactly what happens during pilot whale and orca encounters in the wild. And what those recordings show is, on its face, genuinely strange. Orcas are, under normal circumstances, an extremely vocal species. Constant clicking, constant calling, an ongoing stream of communication used to coordinate hunts, maintain contact with their pod, and navigate their surroundings. They are loud, essentially, because they can afford to be. As the apex predator across most of their range, there is rarely any reason for an orca to stay quiet, since almost nothing in the ocean poses a genuine threat to them. But researchers monitoring these acoustic recordings noticed a specific, repeatable pattern. The moment pilot whale calls begin appearing on the hydrophone data nearby, the orca's behavior shifts abruptly. They go quiet. Vocal communication drops off sharply. Whatever hunting or travel behavior the pod had been engaged in stops, and the group changes direction, moving away from the source of those pilot whale calls, sustaining that retreat at high speed, sometimes for miles, well beyond what would be necessary for a simple, casual repositioning. This is not the behavior of an animal that has decided to hunt elsewhere today out of mild preference. This is the behavior of an animal actively fleeing something it has identified as a serious, immediate threat. Are you still with me? Because I know a sentence like "orcas go silent and swim away" can slide past without fully registering how unusual that actually is. Stay with me, because understanding exactly why this happens is where the story stops being simply interesting and starts being genuinely remarkable. Here is the key difference in how these two species handle danger, and I think it explains almost everything that follows. Most animals in the ocean, when confronted with an approaching orca, respond in one of two familiar ways. They flee, using speed to put distance between themselves and the threat. Or, if they are too slow or too vulnerable to outrun an orca, they attempt to form some kind of defensive formation. Sperm whales, for example, are known to arrange themselves into a tight circle when threatened, tails facing outward, calves protected in the center, using their sheer bulk and positioning as a defensive wall. Pilot whales do not play defense. There is no fleeing. There is no defensive circle. And critically, they never face a threat alone. Pilot whales live in large, tightly bonded social groups, while orca pods typically consist of somewhere between 5 and 15 closely related individuals, a fairly modest family unit. Pilot whale pods commonly range from 20 to as many as 100 whales, and on occasion, multiple pods will temporarily merge into what researchers call superpods, gatherings of several hundred animals moving and acting together. This changes the entire mathematics of an encounter. When an orca or an orca pod encounters pilot whales, it is not facing one aggressive, oddly shaped dolphin. It is potentially facing 50 or 100 coordinated animals, each weighing close to 3 tons, all converging on the same target simultaneously with a single, unambiguous objective: to physically drive that threat completely out of the area. Pilot whales confronted with a perceived threat will ram, chase, and relentlessly harass that threat, sustaining the pressure until it withdraws entirely. It is, in the most literal sense available, coordinated mob behavior, deployed as a defensive and territorial strategy. Now, if you strip away the numbers and picture a strict, isolated one-on-one encounter, the orca wins easily, and there is no meaningful argument otherwise. A 6-ton orca, with jaws built specifically for tearing through flesh, against a 3-ton pilot whale equipped with comparatively small teeth designed for gripping slippery squid rather than inflicting serious damage, is not a fair fight in any conventional sense. But the ocean does not offer isolated one-on-one arenas. It offers risk calculations made in real time by an animal that, for all its raw predatory power, still has to weigh the cost of every decision against the potential reward. Here is the calculation an orca is actually facing in that moment. Yes, it is larger and individually stronger than any single pilot whale nearby. But if it chooses to stand its ground and fight, it is not fighting one animal. It is fighting dozens simultaneously from multiple directions at once. Even in a scenario where the orca manages to kill or seriously injure several pilot whales in the process, and this is a genuinely uncertain outcome to begin with, it is going to sustain damage doing so. It will be rammed repeatedly. It will likely be bitten multiple times. It will be forced to expend enormous amounts of energy defending itself on every side simultaneously, rather than directing a single controlled attack. And in the wild, sustained damage is rarely a survivable inconvenience. A fractured jaw, a torn fin, an injury serious enough to compromise an orca's ability to hunt effectively afterward, does not heal in some controlled, protected environment. There is no recovery period free of further risk, no guaranteed food source waiting while the injury mends. It becomes a slow, likely fatal handicap, since an orca that cannot hunt efficiently in a punishing ocean environment is an orca that is, functionally, already dying, just on a delayed timeline, weeks or months rather than the immediate outcome a single dramatic fight might suggest. Layer onto that one more critical detail. Orcas are not hunting pilot whales for food in these encounters. There is no meal at the end of a successful fight, no caloric reward to offset the risk being taken on. This is, from the orca's perspective, pure downside. All risk, zero payoff. And an animal that has survived long enough to become the ocean's dominant apex predator has, whether through instinct or learned behavior passed down across generations, apparently internalized that basic risk calculation extremely well. 50 against 1, with nothing to gain and everything to lose, is not a fight worth having. And the documented behavior suggests orcas consistently, reliably reach that same conclusion, generation after generation, pod after pod, across entirely separate populations that have no direct contact with one another, which itself suggests this is not a single group's learned quirk, but something closer to a broadly shared, evolved response to an identifiable, consistent threat. But the physical mobbing, as effective as it clearly is, turns out to be only part of the strategy. Pilot whales have a second weapon, and it is considerably stranger than sheer numbers alone. Underwater, sound behaves very differently than it does in open air, and this matters enormously to how these encounters actually unfold. Water is a far denser medium than air, and as a result, sound travels through it at more than 4 times the speed it moves through the atmosphere. In practical terms, underwater sound does not simply arrive as background noise the way it often does on land. It arrives fast, and it arrives with a physical intensity that can genuinely be felt, not just heard. When pilot whales commit to an attack, they do not approach quietly. They scream, producing loud, intense bursts of sound specifically capable of disorienting and intimidating whatever they are converging on. And here is the detail that I think elevates this from simple aggressive noise into something closer to a genuine psychological tactic. Researchers have recorded pilot whales actively mimicking the specific vocal calls that orcas themselves use to communicate. Nobody has definitively confirmed exactly why this mimicry happens, but the leading working theory among researchers studying this behavior is that pilot whales are, in effect, weaponizing the orca's own language against it. Picture the sequence from the orca's perspective. Swimming through dark water and suddenly hearing calls that sound exactly like the communication of its own species. Calls that might, for a critical few seconds, suggest another orcapod is nearby rather than an approaching threat. That brief hesitation, that moment of uncertainty while the orca tries to reconcile what it is hearing, is precisely the window during which the mimicry stops. The genuine, aggressive screaming begins, and 50 or more pilot whales emerge out of the darkness, already at full speed, already converging. It is, in a very real functional sense, an ambush built on acoustic deception layered directly on top of overwhelming numerical force. Confuse first, overwhelm second. So pilot whales can apparently intimidate an animal roughly twice their own individual weight into full retreat. But orcas, for all their fearsome reputation, are still a comparable size class to pilot whales. Tons against tons, a genuine size mismatch, but not an absurd one. What happens when pilot whales encounter something dramatically, almost incomprehensibly larger? Because they share the same deep water hunting grounds with the largest toothed predator that has ever existed on this planet, the sperm whale. A fully grown sperm whale can reach roughly 60 feet in length and weigh up to 50 tons. For context, that is somewhere in the range of 15 to 20 times the weight of a single pilot whale. And crucially, sperm whales hunt the exact same prey, deep sea squid, in the exact same dark, crushing depths, which means their paths regularly cross. You would reasonably assume that a 3-ton pilot whale, encountering a 50-ton sperm whale, would simply give it a wide berth. That size gap is, on paper, not remotely comparable to the orca situation. It should not even register as a contest worth attempting. Pilot whales apparently disagree entirely. Marine biologists have directly documented pilot whales actively mobbing and harassing sperm whales, and the motivation behind it is almost audacious in its simplicity. They are stealing food. This specific behavior has a formal scientific name: kleptoparasitism, essentially theft as a survival strategy. One organism deliberately living off resources captured through the effort of another. It is a recognized behavior across parts of the animal kingdom, frequently observed among birds, where one species will chase another off a food source rather than hunt for itself. But seeing it play out between two of the largest predatory marine mammals on the planet, one stealing from the other purely through coordinated intimidation, is a considerably rarer and more dramatic version of the same basic strategy. Here is how it actually plays out. A sperm whale does the difficult, dangerous, energy-intensive work of diving deep, locating and physically subduing a large squid, sometimes a genuinely enormous one. Colossal squid and giant squid both being documented prey items, and hauling that prey back up toward the surface to actually consume it. And right at that moment, just as the sperm whale is finally in position to eat, a pod of pilot whales will swarm in, screaming, ramming, and relentlessly harassing an animal 15 to 20 times their individual body weight, applying pressure until the sperm whale, apparently deciding the aggravation genuinely is not worth it, releases its catch and withdraws. The pilot whales then simply take the squid for themselves. They are, in the most direct sense possible, bullying the largest predatory animal in the history of this planet into surrendering its own meal. Not through force capable of overpowering a 50-ton animal directly, which would obviously be impossible, but through the same relentless, coordinated, high-volume harassment that apparently works just as effectively against an orca several times their size. At this point, a fair question emerges. Why commit to this level of aggression at all? Why deliberately provoke conflict with the ocean's most feared predator, and separately with its largest one? rather than simply avoiding both and living a quieter, lower-risk existence, the way most other marine animals manage to do? The answer traces directly back to how pilot whales raise their young. And once you understand it, the aggression stops looking reckless and starts looking like a very specific, carefully evolved solution to a very specific problem. Adult pilot whales, as established, are capable of diving to depths exceeding 3,000 feet to hunt. Their calves cannot do this. A young pilot whale's lungs and overall physiology are simply not developed enough to withstand that kind of extreme, sustained breath-holding dive. Which means that whenever the adults descend into deep water to hunt, the calves are left behind, near the surface, unable to follow. And the surface of the open ocean, for an unattended calf, is a genuinely dangerous place to be. It is exposed, offering no cover, and it is regularly patrolled by exactly the kind of predators capable of preying on a young, vulnerable animal: oceanic white-tip sharks, great white sharks, and of course, orcas themselves. If pilot whales responded to approaching threats the way most animals do, quietly avoiding confrontation, staying still, hoping not to be noticed, an orca patrolling the area would eventually locate the exposed calves and take them. Evolution, in this specific context, appears to have settled on a very different and considerably more aggressive solution. If you violently, overwhelmingly attack anything that approaches your territory, nothing ever gets close enough to discover that vulnerable calves are present at all. By committing to relentless, coordinated aggression against literally anything that enters their space, orcas included, sperm whales included, pilot whales create what amounts to a violently enforced exclusion zone around their pod. Nothing threatening gets a chance to identify a target, because nothing threatening survives the approach long enough to actually look. Given everything covered so far, it is worth briefly addressing what would actually happen if a human being ended up in open water alongside a hunting pod of pilot whales. The reasonably good news is that pilot whales do not view humans as prey. Their diet is built entirely around squid, and a human body does not remotely resemble a squid in shape, movement, or acoustic signature underwater. That said, safety is not quite the same as being entirely without risk. These remain animals weighing multiple tons, moving at high speed, communicating through intense bursts of sound, and actively, aggressively defending their space against anything they perceive as an intrusion. A human in the wrong place at the wrong moment is, at minimum, an obstacle rather than a target. And getting struck by an animal of that mass moving at speed carries real physical consequences regardless of intent. There are documented reports of divers who ventured too close being seized and pulled briefly underwater before being released. Less a predatory act, and more, functionally, a forceful eviction notice. To understand how 50 or 100 animals manage to coordinate this level of aggressive behavior so consistently without hesitation or internal disagreement, we need to look at the social structure holding the entire pod together, because this is also where the story takes its darkest turn. The name pilot whale itself traces back to early observations made by fishermen and whalers, who noticed something specific and consistent about how these groups move through open water. The entire pod, whether numbering 20 animals or well over 100, reliably follows a single leader, the pilot the name refers to. Pilot whale society is organized matriarchally, structured around the leadership of an older, experienced female. This individual effectively directs the pod's behavior in its entirety. She determines when the group dives, when it travels, and, critically, when it commits to an attack. The social bonds holding a pilot whale pod together are extraordinarily strong. Members share food with one another, collectively help care for and protect each other's calves, and typically remain with their maternal family unit for the entire span of their lives. Functionally, a pilot whale pod behaves less like a loose collection of individuals and more like a single, coordinated organism, one where individual whales do not appear to make significant independent decisions apart from the group. When the leader moves, the entire pod moves with her, immediately, without visible hesitation or internal disagreement. This is precisely what makes their mobbing behavior against orcas and sperm whales so consistently, reliably effective. Because the entire pod acts as one unified, perfectly synchronized unit, rather than 50 separate individuals making 50 separate decisions under pressure. They are able to overwhelm predators many times larger than any single pilot whale through sheer coordinated commitment, with none of the hesitation or fragmentation that might otherwise let a larger, more powerful animal exploit gaps in a less unified group. But in biology, this level of extreme social loyalty rarely comes without a serious, sometimes fatal cost. Any system that concentrates decision-making entirely within a single point of failure carries an inherent structural vulnerability, and pilot whale society is built almost entirely around exactly that kind of concentration. If an entire pod of 100 whales relies completely on the judgment of a single leading female, what happens in the moment that leader makes a critical mistake? What happens if she becomes disoriented, whether through illness, an infection, old age, or exposure to disruptive underwater noise such as military sonar, a documented factor in several real-world stranding events? Researchers investigating stranding sites have, in a number of cases, found evidence consistent with acoustic trauma or disorientation in the lead animal, though pinpointing an exact cause after the fact remains genuinely difficult, since so many potential factors — illness, parasitic infection affecting navigation, geomagnetic anomalies, and man-made noise — can all produce broadly similar outcomes. If that leader, disoriented for any reason, swims into dangerously shallow water or directly toward a beach, the rest of the pod does not pause, assess the situation independently, and correct course. Independent navigational decision-making does not appear to override the deeply ingrained instinct to remain with the group. If the leader swims onto sand, the pod, near universally, follows her onto the sand, an outcome that, for an animal entirely dependent on open water to survive, is not a minor miscalculation. It is frequently fatal. This directly explains a grim, well-documented pattern. Pilot whales are, statistically, the species most frequently involved in mass stranding events anywhere in the world. And these are rarely small, contained incidents involving 2 or 3 disoriented animals. Entire pods, sometimes numbering in the dozens, or in especially severe cases, the hundreds, will strand themselves simultaneously on the same stretch of beach at essentially the same time. Some of the largest recorded mass stranding events in marine biology history have involved pilot whales specifically. Entire coastlines suddenly covered with dozens or hundreds of stranded animals within the span of a single tide cycle. Events significant enough to mobilize entire regional emergency response networks and draw international media attention. When strandings like this occur, human volunteers frequently respond in large numbers, spending hours pouring water over exposed animals to prevent their skin from drying and overheating, and waiting for a rising tide to create enough depth to physically guide the whales back out into open water. But the most genuinely difficult part of these rescue efforts is what often happens immediately afterward. If the original disoriented leader remains stranded, or if rescued whales can still hear the distress calls of pod members still stuck on the sand, whales that have just been successfully returned to open water will frequently turn around and swim directly back onto the beach. They do not appear capable of simply leaving distressed family members behind, even when remaining means slowly suffocating under the crushing weight of their own body mass. no longer supported by the buoyancy of water. Their underlying social instinct is, apparently, stronger than their individual instinct for self-preservation. Functionally, they would rather die together than survive separated from the rest of the pod. Rescue workers who have spent entire days repeating this cycle, guiding whales back to sea, only to watch them return to shore hours later, frequently describe it as one of the most emotionally exhausting experiences in wildlife rescue work, precisely because the animals are not resisting help out of panic or confusion. They appear to be making a consistent, repeated choice. This is, I think, the detail at the very center of this entire story. The exact same trait, absolute, unwavering social loyalty, that transforms pilot whales into an animal capable of routing the ocean's apex predator and stealing food from its largest living creature, is precisely the same trait capable of destroying dozens or hundreds of them within the span of a single afternoon. It is not two separate characteristics sitting side by side, one a strength and one an unrelated flaw. It is a single trait, extreme social cohesion, producing both outcomes simultaneously, depending entirely on whether the leader making decisions for the group happens to be right or wrong in that specific moment. When you step back and look at the pilot whale as a complete picture, this is essentially what happens when evolution optimizes as aggressively as possible for one single variable, social loyalty, above nearly every other consideration. On one side of that equation, you get an animal capable of sprinting through pitch darkness at crushing depths to hunt prey most predators could never catch. An animal capable of stealing a meal directly from a 50-ton sperm whale through pure coordinated harassment. An animal capable of making the single most feared predator in the ocean go completely silent and flee for miles without ever throwing a single strike. They are, by any reasonable measure, close to untouchable, purely because they refuse to face any threat alone and refuse, ever, to back down as a group. But an advantage engineered this completely, this specifically, rarely arrives without an equally serious cost attached. The price of being the ocean's most fearless, most cohesive mob is the near total loss of independent, individual survival instinct. Together, they are close to invincible. Alone, or more precisely, whenever their collective judgment fails at the top, they are entirely, catastrophically vulnerable. If the leader is right, the entire pod thrives. If the leader is wrong, the entire pod can be lost, together, on the same afternoon, on the same stretch of sand. And yet, for as long as that matriarch continues making the right calls, in the darkness, 3,000 feet down, chasing squid at speeds that should not be survivable, the pilot whale remains one of the only animals in the entire ocean that even the orca has learned, reliably and repeatedly, not to challenge. The surface is not the whole story. It never was. If this documentary gave you something you did not have before you pressed play, if you will never look at a pilot whale or an orca quite the same way again, then subscribe to Abyss Files. Every week we go somewhere the surface does not show you. Every week there is something the ocean is still hiding. And I promise you, it only gets stranger from here.